Welcome, and I'm excited to have you here and join us today for our very first YouTube Premiere event. My name is Patrick Farrell, and I'm Senior Marketing Manager for Simcenter 3D. It's my pleasure to present to you the new features and enhancements that we've made to this latest release of Simcenter 3D 2021.1. Meeting complex engineering challenges requires an efficient and orderly approach. However, having the right tools and framework can make a world of difference in how quickly and faultlessly these challenges are met. This is why product engineering teams need a unified and shared platform for all simulation disciplines. Simcenter 3D offers such a platform with leading-edge analysis tools, more productive workflows, and demonstrably consistent results. We make it that much easier to meet these challenges by continuing to enhance on our 4 unique strengths. The first is faster CAE processes. This means you spend less time modeling and more time on engineering. Next is multidiscipline integration, where you can perform more simulation types all from within a single integrated environment. Being tied to the digital thread means connecting simulation to your broader development process, and being open and scalable is the ability to scale simulation across different user profiles and other simulation tools. So before I get into specifics on what we've done for faster CAE processes, let me explain a little bit more about what that means. So Simcenter 3D is an integrated environment in which you do all of your CAE pre- and post-processing. Within this environment, Simcenter 3D offers unrivaled geometry manipulation tools that can handle CAD data from any source, provide comprehensive meshing and modeling for multiple simulation applications, and deliver the unique capability to associate the analysis model to design data. This helps you speed the tedious modeling process and keeps your analysis models in sync with the latest design. And what this does is this translates into much faster CAE processes than can be achieved with traditional CAE tools. So now let's get into some of the new capabilities that we've added that lead to faster CAE processes. And one of the very first things you'll notice in this release is that we've refreshed the welcome screen to quickly provide you with more valuable content in 4 specific tabs to help you improve your experience in the software. The first tab is called the Highlights tab, and this highlights interesting new features through short videos which explain what these features are and why they might be interesting for you to try. Next is the What's New tab, which gives a comprehensive feature-by-feature list of what has changed in this release compared to previous versions. And if you're new to Simcenter 3D, well, welcome! This next couple of tabs in the welcome screen are really for you. In the New Tips for Newcomers tab, we've handpicked some useful tips and important resources to help get you started. And in the CAE Day 1 tab, you'll find a few noteworthy and essential tutorials to get you started on your CAE journey within Simcenter 3D. Within the Simcenter 3D user interface, there's a new Predictive Command Bar located on the far right-hand side of the screen. Simcenter 3D will show the next most likely commands that you'll use in the Predictive Command Bar based on your past usage over time. These commands are ranked in terms of the most likely command that you're going to need next. As you progress through your workflow, the commands displayed in the Predictive Command Bar will change depending on what Simcenter 3D thinks you'll need next. The adaptive user interface can help you save time, so you don't need to hunt through the main ribbon to find the next command that you're going to need. Beyond user interface enhancements, we also continue to find ways to make CAE processes faster for specific application areas. In Simcenter 3D 2021.1, we've added the ability to reduce model size and computation time through the use of superelements for rotor dynamics simulation. A superelement is a condensed model made of matrices and vectors. Superelements reduce the model size and thus overall computation time during the solve. Superelements are nice for rotor models where you might have repetitive structures or when you need to include linear parts in a nonlinear model. Another benefit of superelements is that they facilitate the exchange of models when working collaboratively, where model details and intellectual property might need to be protected. Any type of model can be represented by a superelement, a 1D model, a 2D model made of axisymmetric elements and Fourier harmonics, or a 3D rotor. And multiple superelements can be assembled together into an analysis. Another application that we've focused on improving speed and accuracy for is in the area of additive manufacturing process simulation. Most other additive manufacturing simulation tools use a voxel mesh for their simulation model. A voxel mesh is a rough hexa type of mesh, but it doesn't really accurately represent the geometry. However, Simcenter 3D additive manufacturing uses an exact meshing method, meaning a mesh more like a traditional finite element analysis mesh. The specimen on the build tray will be exactly meshed with Simcenter 3D TEP meshing functionality in combination with the unique immersed support meshing capability of Simcenter 3D additive manufacturing. This allows you to capture geometric details of the specimen correctly and generate a consistent mesh for the specimen, support structures, and surrounding powder. However, the trade-off to using exact meshing is that the meshing procedure can be challenging for complex parts. In Simcenter 3D 2021.1, the automatic meshing procedure was improved to better deal with model complexity. If for any reason the meshing fails, you can now manually defeature idealized geometry, correct mesh mating conditions, and modify CAE geometry and control mesh settings using the advanced meshing for additive manufacturing. The new advanced meshing workflow breaks the full automation of the meshing process and allows the user to switch to standard Simcenter 3D pre-post and use these functions for the idealized part and mesh file. The advanced mesh workflow allows you to correct mesh failures with manual meshing methods to generate a good quality mesh for complex parts. Electrical machines present unique meshing and modeling challenges. Enhancements in Simcenter 3D 2021.1 allow for large, complex electric motors and transformers to be quickly simulated. Tight air gaps and complex windings can be efficiently modeled, meshed, and solved. So materials are everywhere, and today we see new materials being introduced to the market at unprecedented speed. Studies show that 70% of all new products involve some degree of material innovation. In response to this trend, Siemens recently introduced the Simcenter 3D Materials Engineering product module over the past year, starting in Simcenter 3D 2020.1. In this latest release, we've made crack modeling capabilities faster, as cracking is a very important consideration for advanced materials. Micro and mesocracking in advanced materials are difficult to model with the finite element method, and in Simcenter 3D 2021.1, we've made the task easier by adding full representative volume element separation and automatic insertion of cohesive zones in between different materials. Microstructural models now allow for full mesh separation for a crack to propagate completely through a material. Finally, in every release, we also look to make CAE processes faster through general improvements to performance, and this release is no exception. In Simcenter Nastran, vibroacoustic simulations with pre-computed mode set, a significant reduction in CPU time, memory usage, and file size means you can get the same accurate results faster than in previous versions. For fluid structure interaction applications, the fluid mesh deformation can be difficult to compute for some types of simulations. In this release, a new robust mesh moving method helps speed the process. A new inverse distance weighting method and Laplace smoothing equation method are available as advanced parameters for the mesh movement method. In the dynamics domain, we've also improved Simcenter Nastran binary mode set performance, and we've also made some memory fixes. The solution time for binary mode set is 3 times faster compared to the previous version in Simcenter Nastran. The memory footprint required to solve medium-sized problems has also been significantly reduced. For durability, Simcenter 3D 2021.1 offers the fastest durability solver on the market. Now up to 82% faster, new algorithms have been implemented for calculating stress life, strain life, welding and duty cycles with no order effect. Over the past couple of years, Simcenter Nastran has introduced the multi-step nonlinear solver, and in this latest release, runtimes are faster than ever. For example, we've improved the scalability and architecture of the solver used for Solution 401, which has resulted in a 20% serial performance improvement. For Solution 402, a new version of the MUMPS Direct Solver and parallelizing the modal solver gives a runtime improvement of 31%. So now let's move on to the area of multidiscipline integration. Simcenter 3D integrates industry-standard multidiscipline simulation solvers, all from within a centralized engineering desktop. The Simcenter 3D simulation solvers for structures, thermal, flow, motion, acoustics, structural dynamics, durability, electromagnetics, and more help you to predict real-world performance for a large variety of physics domains. This tight integration of solutions streamlines multiphysics processes that would otherwise be too challenging to perform. In each release, we continue to expand the breadth and depth of analyses that you can use to tackle the challenges that you face in understanding your product's performance. And this release is no different. Acoustics engineers use simulation to understand the noise that's produced from various vibrating components or products. But it's interesting that much of the acoustics analysis is done visually using charts and graphs. Wouldn't it be great to really actually hear the noise that your simulation is predicting instead? Well, now you can. In this release, Simcenter 3D introduces a new Oralization Post-Processing tool, which adds another dimension in the analysis and evaluation of the performance of your design. Simcenter 3D can generate a mono audio profile for a time domain signal. Hear the difference for yourself as we compare the computed pressure sound noise generated by a solid gear and a lightweight gear design. For those of you who design and develop flexible pipes and hoses, such as brake hoses, you're probably already familiar with or maybe even use Simcenter 3D Flexible Pipe. Simcenter 3D Flexible Pipe allows you to simulate mounting scenarios, calculate initial and operating positions, and calculate forces and moments within a hose. In addition, it can be used to validate designs by checking for excessive curvature or collision with other objects, and even look at crushing. But because hoses like these are constantly moving and getting cycled through various positions, it's important to determine the expected lifespan of hoses or cables, including their connecting elements, through fatigue analysis. In this release, the stress tensors from Simcenter 3D Flexible Pipe modules can be available as input into the Simcenter 3D Specialist Durability Solver in order to predict fatigue and failure. This completes the full design loop, as product life is an important criterion used to evaluate the best hose and cable design to avoid product recalls. In the realm of rotor dynamics, misaligned sections of a rotor, even just slightly, can create conditions that are detrimental to the overall system performance. In Simcenter 3D 2021.1, you can now study the effect of rotor misalignment in the structure. Misalignments can be defined between two rotors for parallel, angular, or axial offsets, or even a combination of all of these misalignment types, with the condition that both rotors rotate in the same direction at the same speed. This solution is available in both the frequency and time domains. As an example, let's take a rotor on which we define a parallel and angular misalignment at this location. The geometric misalignment load can be taken into account in a frequency response or in a transient response analysis. When viewing results, we can monitor the forces at the location of the misalignment, and we can also visualize and animate the deformed shape of the rotor. Also in the world of rotating equipment, you can now obtain more accurate stresses in a turbine engine system model. Simcenter Nastran multi-step nonlinear now supports models with combined 2D axisymmetric and 3D cyclic symmetric components. This type of model is useful for efficient modeling of turbine engine systems, which consist of multiple blade stages. Critical blade stages, where accurate stress levels are needed, are modeled with a detailed 3D mesh. Other stages can be modeled using more efficient 2D solid elements. The same property scaling for 2D, 3D coupled models has also been implemented in Simcenter 3D Thermal. It's thus possible to use the 2D, 3D coupled model in either a structure-only Simcenter Nastran model, a thermal-only Simcenter 3D thermal model, or a co-simulation of Simcenter Nastran and Simcenter 3D thermal model in the Simcenter 3D multiphysics environment. Simcenter 3D has long offered the ability to correlate your simulation results with data obtained from physical tests. Correlation helps you gain confidence that what you're simulating is actually predicting reality. In this latest release, you can now include operational shapes in a correlation solution process to compare any combination of operational and mode shapes coming from test or analysis. Mode shape estimation requires the measurement of input forces, which can be difficult or even impossible to obtain. Operational shapes don't require force input measurements and are recorded under real-life conditions, such as when a structure is being qualified, like a spacecraft on a shake table, for example. Comparing operational responses with mode shapes can provide valuable insight into the degree of participation of one or more modes at key frequencies, especially in the presence of closely spaced modes. For example, you can identify the modes and frequencies of the standalone antenna in the vibration response of a complete spacecraft. Comparing test and analysis operational shapes can calibrate the FE model when mode shapes can't be obtained. Comparing two sets of operational shapes can shed light on the effect of different loading conditions on key responses of the structure. In the thermal and flow physics domains, Simcenter 3D has offered a few different modules with differing capabilities, which could also be combined for streamlined multiphysics thermal flow simulations. But in the interest of simplicity and for providing comprehensive capability, we are introducing a new Simcenter 3D thermal multiphysics module, which brings all Simcenter 3D thermal and flow-related project modules together into one single product offering. And this new product module is available to both existing and new customers. Moving to the new thermal multiphysics product is beneficial because you'll be able to access more capabilities from just one product module without having to know if you have all of the necessary modules needed for your application. This results in a simplified product structure, and you gain immediate access to the full breadth of advanced thermal fluid multiphysics simulation capabilities. As part of the Simcenter portfolio of simulation tools, Simcenter 3D integrates with the digital thread that spans 3D simulation, 1D simulation, and testing solutions. However, simulation is just part of a longer digital thread running throughout your product development processes. Simcenter 3D also keeps your simulation tied to this longer thread through a seamlessly managed environment that connects with simulation data management. This keeps your simulation processes in sync with digital development processes from product requirements to CAD, routing, and even manufacturing processes. With this release, we continue to eliminate boundaries between CAE and the rest of the development process, and we introduce new areas of integration between Simcenter 3D and the complete development thread. Electrification is increasing in the industry, which means even more wiring and more complex wire harness design. I previously mentioned the Simcenter 3D flexible pipe product earlier in this presentation, and did you know that Simcenter 3D flexible pipe can also help you rapidly design electric cables and wire harnesses? Well, it can. And with the already existing bidirectional link with the NX routing solution and the use of nonlinear materials, Simcenter 3D can help you define a bundled object consisting of cables enclosed in an external protection layer. It can also help you accurately position and perform clearance checks of of the harness, as well as evaluate mounting and movements of the electrical flat cable. What's new in this release is that Simcenter 3D Flexible Pipe now also is able to benefit from existing ECAD models developed in Capital Harness. The model from Capital doesn't contain any mechanical properties. Simcenter 3D can take that data from Capital to add loads, movements, and material properties to provide an accurate positioning of the wires in the 3D space. After potential enhancements, optimization of the harness model for mechanical purposes, the harness can then also be used for further analyses like electromagnetic interference. Simcenter 3D motion analysis is used for understanding the performance of mechanisms. As part of the digital thread, engineers often connect software models with physical hardware for hardware-in-the-loop simulations. You can use existing Simcenter 3D motion models for real-time applications using a new process to export the model to external platforms. This can save you time by using high-fidelity model-based systems models directly in real-time applications, which removes the need to reduce the model and available parameters or recreate the model in another program. The new export model workflow walks you through the steps to generate the files required to integrate the Simcenter 3D motion model in other platforms like Simulink or real-time platforms like Procyon, Concurrent, and DSpace. Simcenter 3D is a scalable platform on which you can build automated routines to drive repeatable and complex simulation processes. This means simulation capabilities can be scaled from expert analysts doing research to general analysts doing production simulation work, all the way to design engineers and designers looking to get early performance feedback on their designs. And in this release, we've scaled Simcenter 3D's thermal analysis capabilities into a new vertical solution that can be used by mold designers and design engineers using NX for rapid thermal analysis of injection mold designs. This new solution is called NX Mold Cooling. The traditional approach for thermal analysis of a mold design requires a significant manual preparation and care to mesh the small cooling channels. This can be tedious and prone to setup errors. The new NX Mold Cooling product lets designers rapidly set up and simulate the thermal performance of an injection mold insert directly in NX. The wizard-based interface and fast, robust meshing make it easy to use yet powerful to validate your thermal designs. You can choose between 1D or 3D thermal flow, select your mold body and cooling circuit, and set up your analysis and run cooling simulation. The tool automatically generates reports for concise summary of results, so you can identify hotspots and view uneven temperatures on the part. Ultimately, this gives you an immediate insight so you can quickly make design changes and compare performance between designs. There's a lot more in this release based on what I touched on, and I'm sure you'll find more benefits that can help you with your specific applications so you can perform them better and faster. Before concluding, I also want to remind you about the Simcenter community, which is a forum where you can discuss topics on using Simcenter 3D and Simcenter Nastran and all of our other Simcenter products with other customers and users of those tools. It's a great source of information, and if you haven't signed up already, I highly suggest that you check it out. Another great source of information is our support team. And you may have even recently seen some of the Simcenter TV episodes, which have been great at highlighting tips and tricks and showing how you can use Simcenter 3D and our other simulation tools for a wide variety of applications. So please visit our support center to learn more. And finally, thank you for joining us today, and we hope you've enjoyed today's presentation here on YouTube. Take care, stay safe, and now go out there and engineer innovation.